Hello. In this video, we're going to find the first and second derivatives of the function y equals 4x to the negative 2 minus 3 divided by x. We'll start by taking the first derivative, and our first step will be to use the derivative sum rule, which says if u and v are differentiable functions of x, their sum, u plus v, is differentiable at every point where u and v are both differentiable. Then d dx u plus v equals du dx plus dv dx. This allows us to rewrite our function as d dx 4x to the negative 2 minus d dx 3 divided by x. To take the first derivative of 4x to the negative 2, we'll use the constant multiple rule and the power rule for negative integers. The constant multiple rule tells us that if u is a differentiable function of x and c is some constant, d dx cu is equal to c du dx. So we write 4 dx to the 4 d dx x to the power of negative 2. Now we utilize our power rule. The power rule says that if n is a negative integer, well, the power rule for negative integers, that is, states that if n is a negative integer where x is not equal to 0, d dx x to the power of n is equal to n times x raised to the n minus 1. In other words, we take negative 2 multiplied by 4x raised to the negative 2 minus 1. This gives us negative 8x to the power of negative 3. Now let's evaluate d dx 3 divided by x. We'll rewrite 3 divided by x as 3x to the negative 1. Next, we'll use our constant multiple rule and our power rule for negative integers. So we'll multiply negative 1 times 3x raised to the power of negative 1 minus 1, which gives us negative 3x to the power of negative 2. Now we're ready to put the pieces together. So we have negative 8x to the negative 3 minus negative 3x to the negative 2. We can simplify this to get negative 8 over x cubed plus 3 divided by x squared. This expression represents the first derivative of our function. Now let's find our second derivative. We'll use the same steps as before derivative sum rule, constant multiple rule, and power rule for negative integers. But this time we'll streamline the process just a little bit. I'll start by rewriting my expression. So I have negative 8x to the negative third plus 3x to the negative 2. Now, evaluating negative 8x to the negative third, I'll bring negative 3 out in front, multiplied by negative 8x to the negative 3 minus 1, plus negative 2 times 3x to the negative 2 minus 1. This gives us 24x to the negative 4 minus 6x to the negative 3, which can be rewritten as 24 divided by x to the fourth minus 6 divided by x cubed. And this is our second derivative. This concludes our example for finding first and second derivatives for a given function. I hope you found it helpful, and we'll see you next time.